Hello students, this lesson is about piecewise functions, and we're going to write and graph piecewise functions and use them to describe situations. We're going to learn about stepwise functions as well. So a piecewise function is a function that is a combination of one or more functions. The rule for a piecewise function is different for different parts or pieces of the domain. For instance, movie tickets prices are often different for different age groups. So the function for movie ticket prices would assign a different value, ticket price, for each domain interval, age group. Okay, so just a quick note on notation before we move on to the actual problems. If we use square brackets, that means that the endpoint we're talking about is included. Whereas if we used curved brackets, then that endpoint is not included. Okay, so let's see if we can create a table and a verbal description to represent this graph. So when I look at the graph, I can see that I have a couple different prices for the different weights. I have a price of $8 for this weight going from 0 to 2. Then I have a price of $6. Let's see. Okay, going from 0 to 2, I have a cost of $8, and you can see that the dot is open right here at 2. So if you have 2 pounds, it does not cost $8. It jumps down and costs $6. Then going from 2 all the way to 4, or 2 all the way to 5 actually, right? From 2 to 5, the price is $6. Okay. And then if you have 5 or more pounds here, then it costs $5. The domain of the function is divided into 3 intervals. We have the weight under $2, which goes from 0 to 2. So notice the brackets, the 0 is included here, but the 2 was an open dot. The weights from 2 and under 5. So going from 2 to 5, we have this interval. Here the 2 is included, but the 5 is not. And then going from 5 to infinity. Okay. Mixed nuts. So now let's write a description in words. Mixed nuts cost $8 per pound for less than 2 pounds, $6 per pound for 2 pounds or more, and less than 5 pounds, $6 for 2 pounds or more and less than 5 pounds, and $5 per pound for 5 or more pounds. A piecewise function is a piecewise function that is constant for each interval of its domain, such that the ticket price function, is called a step function. So if it has constant, like it's flat for each part, it's called a step function. You can describe piecewise functions with a function rule. The rule for the movie tickets prices would be like this. So we can say we use a bracket to connect all 3 pieces, and we give the price and then the range for each of the prices. So you would read this as f of f is 5 if x is greater than 0 or less than 13. F of x is 9 if x is greater than or equal to 13 or less than 55, and f of x is 6.5 if x is greater than 55. To evaluate any piecewise function for a specific input, find the interval of the domain that contains that input, then use the rule for that interval. So, if we're trying to evaluate the piecewise function for x equals -1, we need to find which piece would contain the x of -1. Here, x is less than or equal to 2, and on the bottom one, x is greater than 2. Well, since we're plugging in -1 and -1 is less than 2, we're going to use the first piece. So we're going to plug -1 into x on the first piece. So we would have 2 times -1 plus 1, which gives us h of -1 to be -1. If we're evaluating x equals 4, since 4 is more than 2, we're going to use the bottom function. So we're going to plug 4 into the bottom function and have 4 squared minus 4, which gives us 12. Okay, if we're trying to plug in -1 into this function, which piece do we use, the top or the bottom? This one says x is less than or equal to -1, so we're going to use the top piece. And we put in -1 and we get 1/2. And if we're plugging in 4, okay, we would use the bottom function and we would get 20. You can graph a piecewise function by graphing each piece of the function. So if we're going to graph this function, we're going to have to graph both of these lines. And we can graph the lines using y equals mx plus b. So we're going to graph, let's see. The function is composed of two linear pieces that will be represented by two rays. Because the domain is divided by x equals 0, evaluate both branches of the function at x equals 0. So here's how we would graph it. In order to graph this first line, I see that my y-intercept is 3, so I'm going to start at 3 and put a point. Then my slope is 1/4, so from that point I'm going to go up 1 over 4 and put another dot, and that's going to be my line. But I'm not going to draw the entire line all the way across the paper. The only part of the line I'm going to draw is where x is less than or equal to 0. So even though I said up 1 over 4, and drew my line like this, I'm going to continue that line in the other direction over here. Okay. So here's down 1 over 4, okay, because I'm only drawing the part of the line that is less than, where my x-axis is less than 0. Then my other part of the axis I can also start on the same y-intercept of 3, and my slope is -2, so down 2 over 1. Okay. And notice that for the second function, the dot is colored in because it says greater than or equal to 0. Let's graph another one. Here, in order to graph this one, we're going to have to start on the y value of 4. Okay, and we're going to draw just a horizontal line right there at 4. The function is composed of two constant pieces that will be represented by two rays. Because the domain is divided by x equals -1, evaluate both branches of the function at x equals -1. So the function is 4 when x is less than or equal to -1. So here's -1. I'm going to come all the way up to 4, and we're going to draw the line less than from there. Okay, and then the function is -2 when x is greater than or equal to -1. So here's my x is greater than -1. It's going to be on this side. Come to -2, and this time it's an open dot. Okay, let's see if we can graph this next function. Actually, okay, when we looked at the previous graph there, notice that the graph jumped. Notice that the piecewise functions are not necessarily continuous, meaning that the graph of the function may have breaks or gaps. To write the function rule for a piecewise function, determine where the domain is divided and write a separate rule for each piece. Then you can combine the pieces to write using the correct notation. So let's look at this next example. The next example happens to use distance equals rate times time. So let's look at this example. Jennifer is completing a 15.5-mile triathlon. She swims 0.5 miles in 30 minutes, bicycles 12 miles in an hour, and runs 3 miles in 30 minutes. Sketch a graph of Jennifer's distance versus time, then write a piecewise function for the graph. So here we can see that that she swims, okay, for the first half of an hour, and that she goes a half of a mile. So if we divide those two, her rate is 1. So that's what she swam. So she swam from 0 to 0.5. Then she's going to bike for a full hour. So from 0.5 of an hour to 1.5 an hour, that would be a full hour. Okay, she's gonna bike. Okay, and so since she's biking 12 miles, it says 12 miles in an hour, the distance she goes is going to be 12. And her rate, which is the distance divided by the time, is 12. Then she runs for a half of an hour, so that's going to be from 0.5, adding a half hour to this, from 1.5 to 2 is when she's going to run, and she says she goes a distance of 3. She runs 3 miles in 30 minutes. So 3 miles, and if we divide those, we can get her rate, which would be 6 miles per hour. So let's see if we can graph that. Okay, so let's see. Where's my mouse? Okay, after 30 minutes, Jennifer has covered a half of a mile. So here's 30 minutes, a half of an hour, 0.5, and she has gone only a half of a mile. So if I'm counting by 2's here, 2, and then half of that would be 1. So that's how far she's gotten. And then during a full hour from 0.5 to 1.5, she goes a distance of 12 miles. So it needs to go all the way up to 12 plus what she had already done. So it goes up 12. And then the last part of the, from 1.5 to 2, she goes, she completes the race there at the end. Now if we find the equation of each parts of these lines, we can write the piecewise function. So you can use point slope form to find the equation of the line, or you can just use y equals mx plus b. We can get the equation for each line, and that gives us the function. Okay.